Why does a grown cat knead like it's still nursing? Kneading begins within hours of birth. A newborn kitten presses its paws alternately against its mother's mammary glands to stimulate milk flow, a reflex that's purely mechanical, purely survival. The pressure triggers a hormonal cascade. Oxytocin releases in the mother, milk lets down, and the kitten feeds. The motion isn't random. It's a precise, rhythmic signal the body already knows how to send. Every successful need is paired with warmth, satiation, and the scent of the mother. The brain logs this combination. Neuroscientists call it associative conditioning, pleasure wired to a specific motor pattern. The paw pads are dense sensors. Each one contains mechanoreceptors, pressure-detecting nerve endings, and scent glands. When a kitten kneads, it's simultaneously reading texture and marking it with its own chemical signature. By 8 weeks, most kittens are weaned. The nursing stimulus is gone, but the neural pathway it carved, warmth plus pressure plus safety equals reward, doesn't disappear. It goes quiet, waiting for the right conditions to reactivate. A 2017 study from the University of Veterinary Medicine Vienna found that adult cats kneading show elevated activity in the limbic system, the brain's emotional processing core. That's the same region active during nursing. The behavior and the emotion are still linked. Most people assume kneading is comfort-seeking. That's partly true, but it undersells what's actually happening. The cat isn't just feeling safe. It's replaying the oldest emotional memory it has, encoded before its eyes were fully open. Here's the counterintuitive finding. The neural signature of adult kneading is structurally similar to the nursing reflex, not just emotionally adjacent to it. The brain isn't recalling comfort abstractly. It's rerunning a specific archived motor program. Procedural memory, the kind that stores how to ride a bicycle or tie a knot, lives in the basal ganglia and cerebellum. Kneading is stored there, not in episodic memory. The cat doesn't remember nursing. It remembers how. Scent is the trigger that unlocks the archive most reliably. The olfactory profile of a trusted caregiver, their skin chemistry, their fabric softener, their breath, activates the kneading reflex in an adult cat faster than any visual cue. Cats process scent through 2 systems. The main olfactory epithelium handles general smells. The vomeronasal organ, tucked at the roof of the mouth, routes chemical signals directly to the amygdala, the brain's threat and trust assessor. Familiar scent means safe. Safe means knead. Not all kneading is identical. John Bradshaw, a feline behaviorist at the University of Bristol and author of Cat Sense, cataloged distinct kneading patterns that differ in rhythm, pressure, and claw extension. Slow, deep kneading with extended claws tends to appear in cats weaned early. Rapid, shallow kneading without claw extension is more common in cats weaned at the standard 8-week mark. The weaning timeline leaves a measurable imprint on the adult behavior. A 2019 study in applied animal behavior science found that cats weaned before 6 weeks showed higher kneading frequency as adults. The earlier the interruption, the more persistently the behavior resurfaces. The archive runs deeper when the original program ran incomplete. There's a territorial dimension most people miss. The scent glands in the paw pads deposit pheromones onto whatever surface is being kneaded. A cat pressing on your lap isn't just seeking comfort, it's marking you as its own. Feline interdigital pheromones, the compounds released from paw pads, have been partially characterized. They contain fatty acid derivatives that signal familiarity and claimed territory to other cats. The human receiving them can't smell a thing. Other cats absolutely can. Research by Kristen Vitale at Oregon State University's Human-Animal Interaction Lab found a consistent difference between solitary and social kneading. Cats kneading on a human more frequently display slow eye blinks, relaxed ear position, and a lowered tail base, signals of affiliative bonding, not just relaxation. The same oxytocin that once flowed in the nursing mother also rises in the adult cat during social kneading. A 2019 study by Mikel Delgado and colleagues, published in PLOS One, found elevated salivary oxytocin in cats during positive human contact sessions. The ancient hormonal loop is still running, just redirected. Kneading isn't one thing. It's a layered act, part procedural memory, part scent communication, part oxytocin feedback loop, part territorial claim. Each press of the paw activates all of those systems simultaneously. That layered architecture reframes every kneading session you've ever witnessed. The cat isn't malfunctioning or regressing. It's running one of the most sophisticated behavioral programs in its repertoire, one that took weeks of early life to install. There's an older explanation too. Wild cats and feral domestic cats press and scratch at sleeping surfaces before lying down, testing the ground for stability and hidden threats. The kneading reflex may have been co-opted from this nest preparation behavior long before domestication. Domestic cats have lived alongside humans for roughly 10,000 years, beginning in the Fertile Crescent, around 8,000 BCE. That's not enough time for evolution to erase the nest preparation instinct. It is, however, enough time for humans to become the surface being prepared. A 2021 behavioral study from the University of Lincoln found that cats offered a heated blanket at body temperature, kneaded it longer, and with greater claw extension than an unheated blanket of identical texture. Temperature, not softness alone, was the primary trigger. Body temperature matters because it mirrors the original stimulus, the mother's warm flank. The mechanoreceptors in the paw pads aren't just measuring pressure. They're cross-referencing temperature. When both match the archive template, the behavior intensifies. The memory is multisensory. Sound plays a role too. Research by Elizabeth von Muggenthaler on feline purr acoustics found that purr vibration frequency between 25 and 150 Hz overlaps with the sensory range that soothes the feline nervous system. That's the same range present during nursing. When a cat purrs while kneading, it's not just expressing contentment outward. It may be using its own vibration to deepen its own calm, a self-reinforcing loop the nursing context originally established and that the adult brain still knows how to run. That self-reinforcing loop explains why interrupting a kneading cat produces a brief, visible startle. The cat isn't simply relaxed. It's in a specific neurological state, closer to a meditative rhythm than passive rest. Interruption breaks a running program, not just a mood. A 2016 study by Suzanne Schatz at Lund University, examining feline vocalization and neural states, identified elevated theta wave activity in cats during rhythmic self-soothing behaviors. The same brainwave pattern linked to drowsiness and early sleep onset. Kneading suspends the cat between waking and rest, exactly as nursing once did. The practical implication of all this. If you want to invite kneading, the research points to 3 specific conditions: a surface at body temperature, a fabric carrying your scent, and low-frequency ambient sound near the purr range. Match those 3 inputs and you're recreating the sensory template the behavior runs on. We began by asking why a grown cat kneads like it's still nursing. The answer is that it partly is, not in body, but in brain state, replaying an archived sensory template so specific that warmth, texture, scent, and vibration all have to align before the program fully runs. What kneading reveals is that early sensory experience writes durable code in the mammalian brain, code that persists across a lifetime. Feline memory researchers argue this makes the cat a model organism for studying how infant procedural learning shapes adult emotional behavior. The paw on your lap is doing science.